What's the first term in here that it talks about? A monomial. Okay, so this is important that we understand what a monomial is. Okay, so a monomial. First of all, a monomial is a polynomial. A monomial, though, how do you know when you have a monomial? It is a number, a variable, or a product of number and variables. So a monomial can be just a number, can be just a variable, or it can be a product of numbers and variables. And notice what else it says. It does have to have whole number exponents, okay? So let me give you some examples of some monomials. The number 10 is a monomial. If I just say x to the second power, that's a monomial. It's a variable being taken to a whole number exponent. If I say 7y, that is a monomial. It's a product of a number and a variable. If I say negative x squared y cubed z to the fourth power, it is a monomial because it is variables being taken to whole powers, being multiplied by a negative 1 at the beginning, and there's no addition or subtraction going on. It's just a product. All of those were examples of monomials. Well, I said a monomial is a polynomial, because it says right here, a polynomial is a monomial. So as soon as you see a monomial, you say, oh, guess what? You're also a polynomial. So a polynomial is a monomial or the sum or difference of monomials. The sum or difference. And so as soon as you start seeing some terms being added and or subtracted, now you've got a group of monomials that are making up a polynomial. And then one of the things that we have to talk about is degrees. So if we want to find the degree of a monomial, it's different than how we find the degree of a polynomial. The monomial is the only one that gets this rule. To find the degree of a monomial, you add, so we're looking for the degree of a monomial, we are going to find the sum of the exponents. So all those exponents on the variable parts, all the exponents on those variable parts are going to be added together. So here's them doing it with this monomial. Here's the monomial right here, 8x squared y cubed. Is there any addition or subtraction going on in that? No. That's the product of a number 8 and some variables, some x's and some y's, isn't it? There's no addition or subtraction going on. There's one monomial term here. Well, if this is a monomial, then what we do is we look at the exponents. So we have an exponent of 2, we have an exponent of 3. We add those together, and we say the degree of this one is 5. It has a degree, this monomial has degree 5. Could anybody tell me, if I said to you, what's another way we could write 8, you know the 8 part of that monomial? What's another way we could write 8 that would have a variable part that's been cleaned up maybe? Maybe it's just not there because it got cleaned up. What's another name I could give 8 that would have a variable attached to it, but yet it still would be equal to 8? It would not change its value. So if I said to you, would 8x to the first power be the same as 8? Alexis?
Be 8x to the 0 power.
Okay, why would it be 8x to the 0 power?
Because anything to the 0 power is 1.
Anything to the 0 power is 1. And 1 times 8 would be 8. So 8x to the 0 power is really the same thing as 8. So there really kind of is almost like an exponent on that 8. It has an x to the 0 that we can't see. And so, but 0 plus 2 plus 5, or 2 plus 3 is still 5. So we still have a degree 7. Here's our other monomial right here. Negative 4, a to the 6th b. Where did they get that it is a degree 7? Zach? Yeah, so I was wondering where that 1 came from. Well, it's right here, invisible on that B, isn't it? They don't write the exponent of 1. Whenever something isn't shown to an exponent, it's not 0, it's 1. So 6 plus 1, this monomial has a degree of 7, okay? So that's how we find the degrees of monomials. But we have to be a little bit pickier when it comes to polynomials. Because now we're going to talk about how do we find the degree of a polynomial. So the degree of a polynomial, notice it doesn't say add up all the exponents. It says take the degree of the term with the greatest degree. When they say term, you know what they're saying? A monomial. So remember, a polynomial can be made up of just one monomial. And if that's the case, then we're going to add its exponents. But if it has more than one monomial, it has some addition, maybe some subtraction, maybe both going on. Now it's got more than one monomial, and each of those monomials is called a term. So now we have to find the term with the greatest degree. So here's what we do. To find the degree of this polynomial, how many terms does that have? How many monomials are in it? I only see 1, 2. Right? There's only one addition sign there. So it's a 2-term polynomial. It has 2 monomials. So what they did is they found the degree of each monomial. See that right here? They found the degree of each monomial. And they said, oh, okay, well, now that we know the degree of each monomial, it says you have to take the one that has the greatest degree. So the degree of the polynomial is going to be 7. Not 12. Not 7 plus 5. The one that has the biggest monomial degree. And same thing happens in this one. We have this monomial. How many terms does that one have? 2. It has 4ab, and its degree is 2. It has 9a cubed, and its degree is 3. Do we add them together? No, we take the larger of the 2. 3 is greater than 2, so the degree of the polynomial is 3. Okay, we're not going to do standard form quite yet. We're going to go practice these, okay? So let's do number 1. Find the degree of the monomial. Here's the kind of work that you're going to need to show when you're doing it for right now in your notes. I want you to be able to see how did we get this answer. I don't want just an answer on the line. I want you to do this. Degree. To get the degree, here's what we're going to do. Is this a monomial? Okay. What are we going to do to get its degree? Alicia? Add 3 and 5. And yes, the degree will be 8. It's a degree 8 monomial. Okay, you go ahead and do the other 2 now. See what you get. Show what you did to get it. Just like we did in this one. Zach, what's the degree of 6xyz? 3. How'd you get it? 1 plus 1 plus 1. All 3 of these variable parts have an invisible power of 1. So the degree of the monomial is 3. Anybody want to disagree? Okay, number 3. What is the degree of that monomial, also known as a polynomial, of course? Zach? 4. How'd you get 4? 2 plus 2. Okay. So when can we use this strategy? Alicia?
What is a monomial?
When it's a monomial. What does a monomial not have in it? As soon as you see it, you're like, oh, that's not just a monomial, there's something else going on. Trevor? Addition or subtraction. Yeah. We won't have any addition or subtraction going on. Okay, let's look at number 4 then. Is that a monomial? No. How many monomial terms does it have, Connor? 2. So what do we have to do when we have more than one monomial? Find the degree of each of them. So here, I'm not going to make you show the addition. What's the degree of the first monomial? 5. What's the degree of the second monomial? 6. So what's the degree of this polynomial? 6. Not 5 plus 6, the bigger of the two, right? Okay, go ahead and do the other two. What's the degree of each of those other polynomials? Okay, starting with number 5, the monomial term 4x squared y cubed max, what's its degree? 5. The next monomial term y to the 4th power lambda, what's its degree? 4. And the last monomial term of that polynomial counter, what's its degree? No. No. Remember the exponents are on the variable part. Does this one have a variable? If we did stick a variable on it, what exponent would we have to put on it? So what's the degree of this monomial? 0, yeah. Whenever you just have a number and no variable part, it's got a degree of 0, okay? Because it could be 7x to the 0 power. They've cleaned that up. They've said, you know what, x to the 0 power is 1. 1 times 7 is still 7, so I don't need that x there. Okay, so what's the degree of our polynomial class? 5. Okay. Trevor, what's the degree of the first monomial on number 6? 2. What's the degree of the second polynomial, number 6, Sloan? 2. What's the degree of the third monomial on this one, Joss? 1. So what's the degree of the polynomial class? 2. The largest degree of any monomial is 2, so the degree of the polynomial is 2. Okay, anybody have questions on being able to determine the degree? Okay, now let's go back up to the top and look at standard form. Standard form is huge. You have to have an understanding of standard form because you're going to have to write equations in standard form a lot. So standard form means standard form of a polynomial. When you are told to write a polynomial in standard form, they're telling you take the terms and order them from greatest degree to least degree. So you take every monomial term and you rearrange them so that the one that has the largest degree gets to be first, the next largest gets to be next, the next largest, and so on down the line. Then it will be in standard form. So notice what they did. Here's our polynomial here. Is this in standard form, do you think, right now? 5x plus 6x cubed plus 4 plus 2x to the 4th. Here's how we know that it's not. They've already figured out the degree of every monomial. You see that there? Every monomial term. How many monomials are there in this polynomial? 4. There are 4 terms. The first one has a degree of 1, the next one 3, 0, and then 4. Well, that's not greatest to least, is it? So they got rearranged so that the one with the exponent of 4 is first, the one with the exponent of 3 is next, the one with an exponent of what? What's the next one's exponent? 1 is next, and the next one, 0. So now it's in standard form, okay? So now that it is in standard form, now there's another really important thing that they want to make sure that you understand how to do, and that's determine the leading coefficient. Because the leading coefficient of a polynomial often plays an important role. We don't have to talk about that important role today, we just have to know how to find it. So the leading coefficient means what is the first monomial's constant part? What is it being multiplied by? What's the variable being multiplied by? So what's the leading coefficient of this one? 2. So if you did not put it in standard form first, you would have might have said it was 5. But that's not right. So I will let you write leading coefficient like this, LC. The leading coefficient is 2. Okay, so now let's go do some practicing with that. Number 7. Our first move is going to be give the degree of each monomial term. Degree of the first term. 3. Degree of the second term. 4. Degree of the last term. 5. Is it in standard form? 3, 4, 5? No. So who wants to name it how it would be? Zach?
-6x to the 5th power minus 5x to the 4th power plus x to the 3rd.
What do you guys think? You agree with it? Agree with what that? Okay. 5, 4, 3. And the subtractions, kind of like, we have to know how to handle them. We got to make sure they come along properly. Okay, now we have to say what the leading coefficient is, because once it's in standard form, we can properly, accurately describe the leading coefficient. What is it? -6. Okay, you go to number 8. Put it in standard form unless it already is. You can say it already is, and then you can give its leading coefficient. If it's not, get it there, and then give its leading coefficient. Josh, you got this for me? Come on up. Thanks, Josh. Do you guys agree with it? Okay, you agree with the degrees of the monomial terms, or rearrangement of them, and the leading coefficient? Okay, she's right. Good job. Okay, and our last one. Degree of this one is 1. Degree of this term is 2. Degree of the last term is 0. Standard form, how will that go? How will standard form look? Alicia?
7x to the 2nd power plus 8x minus 1.
Okay, that's right. Good job. What's the leading coefficient, class? 7. Okay. So standard form. Now, you need to hear me on something, though. Hear me today on this. You cannot put a polynomial in standard form if it has more than one variable type. Okay, so it can't have x's and y's. Can't have a's and b's. It can't have x, y's, and z's. It can only have one variable type. So notice these. Do they have any more than one variable involved in them? No. That's why we can put them in standard form. We do not put a polynomial in standard form when it has more than one variable type. Okay? We learn how to put them in a form that looks good, but it's not called standard form. Okay, let's go to the back side. Because it was important for us to learn how to do this so that we could know how to classify polynomials, because that's one of the things in our learning goal. I can classify. So we just got done with the writing in standard form. Now we got to be able to classify them. So polynomials have special names. So this is really important. When I say to you, give me the name of that polynomial, this is how you're going to decide what its name is. You're going to figure out its degree. You're going to figure out how many monomial terms it has. And you're going to give it a first name and a last name, just like you have a first name and a last name. So, they've done in this, and so this table, it's kind of, actually you might want to get these memorized. Here's our polynomial that we're going to classify. Is it in standard form right now? 7x to the 4th plus 5x plus 3. How are you feeling about that? Standard form? Okay. Because once it's in standard form, then you just look at its first term, because remember the monomial with the greatest degree is to be the degree of the polynomial. So what's the degree of this polynomial? It's 4. So notice they wrote that, and that's what you're going to do when you're doing these. Degree 4. It has how many monomials? 3. So we look up at the table and we say its first name is based on the fact that it's a fourth degree. What's a fourth degree polynomial called? Quartic. What's a three-term polynomial called? Trinomial. So notice what they said. It's a quartic trinomial. That's its name. So this part right here, polynomials can be evaluated. That's its own section. So let's go practice classifying, okay? So from polynomials can be evaluated down. That's the last thing that we will do. So let's go do number 10 and 11. First thing, here's how you're going to support your answers. You're going to show me your stuff. You're going to tell me what the degree is. You're going to tell me what the number of terms is. And then you're going to give it its first and last name. So Leonard, what's the degree of the polynomial on number 10? 2. So degree 2. You agree, class? Okay. How many terms? 2. Okay. Okay, what's its first name? Quadratic. And learn how to spell these. Quadratic. It's quadratic because it's degree 2. What's its last name? Binomial because it has 2 terms. It is a quadratic binomial. You need to know these things. Okay, go ahead and do number 11 on your own. Give it tell what degree it is, tell how many terms there are, name it, classify it. You got this, Zach? Come on up, finish for me. Thank you. Okay, thank you, Zach. How do you feel about that decision of your results? Do you like it? He says it's degree 3, which makes it cubic. He says there's 4 terms, which makes it a polynomial. Why didn't he give it any sort of special name other than polynomial?
Because 4
4 or more, they don't have them, do they? They're just a standard old polynomial. They don't get any special name. When do they quit getting special names for degrees? 6 or more. So if you had a degree 6 polynomial, you wouldn't be able to call it something. You would say 6th degree. And if it had 6 terms besides, then you'd say 6th degree polynomial because there's no special name for that either. Okay? So sometimes we can't give them the special names. They have to have the standard name kind of we call it. Okay? Okay, let's go do evaluating. Now there is one example up there I'll let you study on your own, but I do want you to get a little bit of homework time, so I want to go through this one with you, number 12. It's like the example up above. You're going to kind of feel like you've been evaluating polynomials long before today when we do this. Because all we're going to do is substitute in, and we're going to work through order of operations and get answer. So a ball is thrown straight up in the air from a height of 6 feet at a speed of 80 feet per second. The height of the ball, look at this, this is important. The height of the ball in feet is given by that polynomial right there. Negative 16t squared plus 80t plus 6. T is the time in seconds. Now, you know what students do when they read all of that kind of stuff? They get confused because they see that 6 and then they see that 80 and then they see this polynomial and then they see this 3 and they're like, where am I supposed to put what? Is the 6 already represented in the polynomial? Yeah, it says plus 6 at the end. They've already taken care of that. Is the 80 represented in the polynomial? Yeah, there's a plus 80t, right? They've already represented 80. You don't got to worry about it. I wonder where the negative 16 came from. That has to do with gravity. Okay, now, they're saying we're supposed to find the height after 3 seconds. So find the height after 3 seconds. So we're going to take this polynomial, negative 16t squared plus 80t plus 6. Oh, by the way, can you give me that name of that kind of polynomial? What do you think that is? trinomial. Yeah, it's a quadratic because it's degree 2, and it's trinomial because it has 3 terms. We're going to evaluate this for t equals 3. They want to know, after that ball has been in the air 3 seconds, how high will it be? So we're going to substitute 3 in for our t's. Wherever we see a t, 3 is going in its place. And then we're going to follow order of operations. Some of us still think we can make up our own order of operations. We take negative 16 times 3 first, or do we square 3 first?
Square.
We square 3 first, okay? So the negative 16 is going to get multiplied by 9, right? What's 80 times 3? 240. 6 is 6. Can't do much with that. Oh, I wonder what negative 16 times 9 is. Let's see, negative 16 times. I'm not even going to worry about negatives right now. 16 times 10 is 160, but I went up 1 too many 16 times. So I gotta subtract 16 from 160. 144, but now of course we're dealing with one negative times a positive, so it's going to be a negative 144. Addition allows us to add in whatever kind of groups we want. So I'm going to add 240 to 6 next. What's that? 246. See, we don't even need a calculator. We are so good. What is a negative 144 plus 246? 102. Now the question is, what did we just find? 102 what? Feet. We were looking for the height of the ball. It's thrown straight up in the air. After 3 seconds, it is 102 feet up in the air. We gotta know what the label is for that also. Okay, think you got this? You have a lot of problems, but they're kind of, they don't take very long to do. Each of them, I mean, they don't take but 5 minutes for each problem. So. Any questions or concerns? Okay.